Welcome. Today we're going to go ahead and review fractions and decimals. Our content objective is students will be able to find the sum, difference, product, and quotient of fractions and decimals. So in simple terms, we're going to know how to add, subtract, multiply, and divide fractions as well as decimals. Language objective is students will be able to explain verbally the essential steps to solving problems with fractions and decimals, as well as read fraction answers correctly. Why am I learning this? Well, it's extremely important for solving equations. Let's go ahead and look at our very first example. We're going to go ahead and start by adding fractions with uncommon denominators. So the first thing that I like to do, so here's a couple of tips, is first check, can the smaller number be multiplied to make the larger number? So in other words, can 2 be multiplied to give me 5? Unfortunately, no. Once that doesn't work, what I start doing is list multiples of the larger denominator. So the first multiple of 5 is 5. 2 cannot be made into 5. Next number would be 10. Can 2 be made into 10? Absolutely. So that's going to be my common denominator. Now, my goal is to somehow turn 1/2 into a 10th. Okay, so how do you make 2 to become a 10? Well, I do that by multiplying by 5. If I multiply the denominator by 5, I'm also going to have to multiply the numerator by 5. Why is this okay to do? Well, let's think about it. 5 over 5 is just 1. So essentially, I'm multiplying 1 and 1/2. Does it change the value at all? No. All it did was simply change the look of the fraction from 1/2 to now, which is going to become 5 times 1, which is 5/10. These are exactly the same value, except now they're expressed in terms of tenths instead of halves. So I'm going to repeat the process here. 5 is not a 10 yet, but I could manipulate it into making it a 10 by multiplying the denominator by 2, which means I must also multiply the numerator by 2. Why again? Because 2 over 2 is just 1. Does multiplying a number by 1 change the value at all? No, so that's okay. So my new numerator is going to be 2 times 2, which is 4, and here you can even see 5 times 2 does give me this 10. Now that they are common denominators, I can go ahead and combine them. 5/10 plus 4/10 will give me 9/10. So you'll notice essentially what happened is we kept the denominators the same because they're in tenths, but we combined the numerator, so 5 plus 4 gave me 9. Now the one thing that you also want to make sure that you do is make sure your final answer is reduced. So I'm going to ask myself, is 9/10 reduced? The answer is yes. So at this point I can go ahead and circle my answer and say the sum of 1/2 and 2/5 is 9/10. Notice I said sum because we were adding the two numbers together. So I'm going to go ahead and go over a couple more examples, and then I'll go ahead and have you try some on your own. So here again we're going to check, can 2 go into 7? Nope. So let's go ahead and list multiples of the larger denominator. Okay, obviously it can't go into 7. Next number would be 14. Can 2 be made into 14? Yes. So that's going to be my lowest common denominator. Now what I'm going to do is go ahead and change the fraction. 2 needs to be multiplied by what to give me 14? Well, it has to be multiplied by 7. So multiplying the denominator as well as the numerator. Because 7 over 7 is just 1, multiplying something by 1 doesn't change it at all. So now my new numerator is going to be 7 times 1. So this is going to be 7/14. Plus, here, right now our denominator is 7, but we want to make it into a 14. So in order to do that, we're going to have to multiply by 2. Multiplying the denominator by 2 would require us to multiply the numerator by 2 as well. So here, the new numerator is going to be 3 times 2, which is 6. And again, you'll see 7 times 2 is what gave us our 14 here. So now, we're going to go ahead and combine 7/14 plus 6/14 is going to give us a total of 13/14. Once again, the denominators stay the same, but we went ahead and combined the numerators. Before we circle our answer and say that it's complete, we want to make sure that the answer is reduced. Is 13/14 reduced? The answer is yes. So I'm going to go ahead and circle my answer, and I am done with the first one. So now let's take a look at the next example. So this one looks slightly different. This one is a mixed number minus a mixed number. So 6 1/5 minus 1 2/3. So the very first thing that I want you to do whenever you see a mixed number, when we're adding, subtracting, multiplying, dividing, is your first step should be to turn that mixed number into an improper fraction. If you need a reminder, what that looks like is you're going to multiply the denominator with the whole number, 6 times 5. Then you're going to add the numerator. So 6 times 5 plus 1 is 31. So it's now going to become 31/5. I'm going to repeat the process with this mixed number. 3 times 1 is 3 plus 2 is 5. So it's going to be 5/3. I do want to address a common mistake that some students do. Some students think this is a -1, so they'll do 3 times -1 plus 2. Please do not do that. Do not consider the sign whenever you're turning a mixed number into an improper fraction. Okay, so now we're at this stage. We're going to go ahead and look for the lowest common denominator. So let's skip a step and just go by multiples of the larger number. Can 3 be multiplied to make 5? Nope. Can 3 be multiplied to make 10? No. Can 3 be multiplied to make 15? Yes. So notice again, I just went by the multiples of the larger number until I was able to make it work. So 15 is our lowest common denominator. I'm going to write that down. Here, 5 times what gives me 15? 3. So I'm going to multiply the denominator by 3 and the numerator by 3. 31 times 3 is, let's see, I'm not sure, so I'm going to go off onto the side work and multiply it out. 31 times 3. 3 times 1 is 3. 3 times 3 is 9. So please notice whenever you're doing math that you can't necessarily do off the top of your head, please go off to the side of your paper and show side work to keep things nice and neat. So here we have 93 minus. Now here, 3 needs to be multiplied by something, give me 15. So I'm going to go ahead and multiply it by 5. To denominator and the numerator. Here we have 5 times 5, which is 25. So here our denominator is going to stay at 15. I'm not sure what 93 minus 25 is off the top of my head, so once again I'm going to do side work. 93 minus 25. So this is going to become a 13 because I need to borrow. This is going to become an 8. 13 minus 5 is, let's see, 8. And then 8 minus 2 is 6. So we have 68/15. Now, here I'm going to notice that it is improper. So what I want to do first is to go ahead and change it back to a mixed. So I'm running out of room, so I'm going to go ahead and show it down here. I'm going to do 68 divided by 15. Well, 15 cannot go into 6, so I'm not going to write anything there. 15 can go into 68, let's say, about 4 times. Which is going to give me 60 with a remainder of 8. So my answer is going to be 4 8/15. So my final answer, I'm going to go ahead and write it down and check that it's reduced. And then it is, so I'm going to go ahead and circle it. So hopefully after these couple of examples, you got the idea now, and you can go ahead and try number 3 and 4 on your own. Let's go ahead and check to see how well we did. For the very first one, we do have a mixed number, so let's go ahead and tackle that first. I do want to address something. If you haven't noticed already, we do have a mixed number, and within this mixed number, our fraction isn't reduced. So if you wanted to reduce that, that might be a good idea. But if you didn't recognize it and you went ahead and just turned it into an improper fraction, that's okay as well. So let's just assume you didn't see it and you didn't reduce it. So let's see what happens. We're going to turn it into an improper fraction by multiplying the denominator and the whole number. So 8 times 4 is 32, and then we're going to add 2, which gives us 34. And it's still going to be in terms of 8s. And then the 1/2 is perfectly fine, so we're going to keep it as that. So again, it's always a good idea to first check, hey, can 2 be multiplied to give you 8? The answer is yes. So we're going to go ahead and say 8 is our lowest common denominator. And yes, we are still adding. So at this point, I like to ask myself, is 8 and 8? Yes, it doesn't need any changing, so the numerator is going to stay exactly the same, which is 834. Here is a 2 and 8. No, not yet. We could make the 2 into an 8 by simply multiplying it by a 4. But we know if we multiply the denominator by 4, we must also multiply the numerator by 4. Why? Because 2 times 4 is what's going to give me the 8, but we also have to change the numerator. So here, 1 times 4 is going to be a 4. So at this point, since they are like denominators, I can go ahead and combine the numerators. 34 plus 4 is 38. And then the 8 remains the same. So it's 38 eighths. This is a mixed number. So in order to do that, let's go ahead and divide. 38 divided by 8. 8 goes into 38 about, say, 4 times, which gives us 32 and leaves us with a remainder of 6. So we're left with 4 and 6/8. Some of you are going to want to stop here. However, be careful. Notice this isn't reduced. I'm going to reduce both the numerator and denominator by a 2 because they have a 2 in common, which leaves me with 4 and 3/4. That would be my final answer. Now moving on to number 4. Taking a close look at our problem, I notice we're not given a fraction, but I can easily turn it into a fraction simply by putting a 1 underneath. Why? Because 11 divided by 1 is still 11. And here we have a mixed number, so we're going to go ahead and turn it into an improper fraction. So we're going to do 15 times 2, which is 30, plus 7, which is 37. So here I'm going to rewrite it as 11 over 1 minus 37 over 15. Again, I always ask myself, can the lower number be multiplied to give me the larger number? So in other words, can 1 be multiplied to give me 15? The answer is yes. So let's go ahead and make that our lowest common denominator. We are still going to be subtracting, so let's see if that's there. 1 is not a 15 yet, so let's go ahead and transform it into 15 simply by multiplying it by 15. If you multiply the denominator by 15, make sure you also multiply the numerator by 15. 15 times 11 is 165, so that part's good. 15 is already 15, so nothing's going to change. I'm going to keep the numerator as a 37. Now, in order to get my answer, I'm going to have to go ahead and first keep the denominators the same, but we're going to have to subtract the numerators. I can't do this off the top of my head, so I'm going to go ahead and do some side work. Let's do 165 minus 37. We're going to have to borrow. This is going to become 15. 15 minus 7 is 8. 5 minus 3 is 2. 1 minus nothing is 1. So we have 128 over 15. But we know very well we're still not finished. We must go ahead and turn it into a mixed number because right now it's improper. So 128 divided by 15. About how many times will that go in? Well, it's going to go in about 8 times. Notice I am placing it under the 8 because it can only go into 128, not 12, not 1. So 8 times 15 is 120. It's going to leave me with the remainder of 8. So I'm going to be left with 8 and 8/15. That would be my final answer. Why? Because this is already reduced. So hopefully you got those right. So now moving on to cross-canceling. Here, what some people may do is with multiplication is multiply straight across. 5 times 9 is 45. 6 times 10 is 60, and then they would have to reduce from here and say, okay, I can divide both the numerator and denominator by 15, which is going to leave me with 3/4. Now, is this an option? Absolutely, but is there a better way? In my opinion, yes. Cross-canceling is going to make your numbers a lot easier to work with, simply by reducing before you start multiplying. So let me give you an example. By cross-canceling, you're going to look at the numbers across from each other, diagonally. So you're going to check here, does 5 and 10 have anything in common? Yes, they both have a factor of 5. So I'm going to go ahead and reduce it. 5 divided by 5 is 1. 10 divided by 5 is 2. So notice my numbers are now smaller. I'm going to repeat the process here with 6 and 9. So here, do 6 and 9 have anything in common? Yes, they have a 3 in common, so let's reduce. 6 divided by 3 is 2, and 9 divided by 3 is 3. So once again, we've reduced the numbers to something smaller. At this point, once we've reduced, we're going to go ahead and start multiplying. Now it's 1 times 3, which is 3, and 2 times 2, which is 4. But before we claim that this is our final answer, double check that it's reduced. The answer is yes. So cross-canceling will make it easier for you to reduce, okay? So please, you want to make sure you're practicing that. Don't just automatically multiply straight across. So with that example, I want you to go ahead, pause the video, and try number 6 and 7 on your own. Okay, so let's see how well you did. For number 6, they're both already fractions, so I'm just going to check, can I cross cancel? Well, yes, we can. A 7 and a 21 have a 7 in common, so we're going to reduce. 7 divided by 7 is 1. 21 divided by 7 is 3. Now looking across at the other numbers, do 8 and 5 have anything in common? The answer is no. So there are times where you can't cross cancel, and that is okay. So I'm going to leave the numbers as 8 and 5. I can't change anything about it. At this point, I can go ahead and multiply straight across, but now I'm multiplying 1 times 5, which is 5, and then I'm going to multiply 8 times 3, which is 24. So my answer is 5 over 24. But before, again, we circle our answer, we got to check, is that reduced? The answer is, yes it is. So that is our final answer. Number 7 is different. Number 7 is a mixed number times a mixed number. So if you remember, with mixed numbers, the first thing you want to do is turn it into an improper fraction. So let's do that. So here, we're going to do 4 times 2, which is 8, plus 1 is 9. So that's going to be 9/4. Here, 3 times 3 is 9, plus 1 is 10, so that's 10/3. Once we've done that, we can go ahead and check to see if we can cross cancel. Let's see, 9 and 3 have a 3 in common, so let's reduce them. 9 divided by 3 is 3. 3 divided by 3 is 1. What about 4 and 10? Guess what? 4 and 10 also have a factor in common. They have a 2 in common. So here we're going to do 4 divided by 2 is 2. 10 divided by 2 is 5. Once we've done that, we're going to multiply straight across and say, okay, well, 3 times 5 is 15. 2 times 1 is 2. Here you'll notice that your answer is improper, so we're going to go ahead and divide 15 divided by 2 to make that a mixed number, which should leave you with 7.5. Okay, moving on. So now we're going to be dividing fraction. Okay, so what's so different about dividing fraction versus multiplying fractions? Because there is a slight difference. When we're dividing fractions, what you first need to remember to do is to remember to flip the second fraction, which you're going to often hear me say as multiply by the reciprocal. Because reciprocal is just the fancy way in mathematical terms of flipping a fraction over. So in an example like this, 4/5 times 2/3, again, I want you to multiply by the reciprocal. Please pardon my horrible handwriting. So here, what I'm going to do is keep the very first fraction as 4/5. And then I'm going to go ahead and multiply, like I said, the reciprocal. So we're going to flip this over and call it 3/2. And guess what? Now we have a multiplication problem just like before, just like a couple slides ago. So what could I do? Well, I can check if I can cross cancel. Could I? Yeah. So here, 4 and 2 have a 2 in common, so let's go ahead and divide that. 4 divided by 2 is 2. 2 divided by 2 is 1. Do 5 and 3 have anything in common? Nope. So I'm just going to go ahead and multiply straight across and say 2 times 3 is 6. 5 times 1 is 5. Now this is improper, so let's go ahead and turn it into a mixed number. I'm going to do some side work. 6 divided by 5, that goes in one time with a remainder of 1. So my answer is 1 and 1/5. Now, is that reduced? The answer is yes. So there is our final answer. So it's really important to remember that when we're dividing fractions, we're going to multiply by the reciprocal. So what ends up happening is you change the division into multiplication, and then you take the reciprocal, which means you flip over that fraction. Okay. Now that you've practiced, I would like you to go ahead and pause the video and try number 7 and 8 on your own. Okay, so let's see how well we did. For number 7, they're both fractions, so I don't have to convert any mixed numbers to improper fractions. So the first thing I want to do is multiply by the reciprocal. So I'm going to go ahead and keep this first fraction exactly the way that it is. I'm going to change this into multiplication, and then I'm going to go ahead and take the reciprocal, so 2 over 1. Now that it's multiplication, I can go ahead and check if I can cross cancel. Does 3 and 1 have anything in common? Nope. Do 8 and 2 have anything in common? Yes, we're going to go ahead and divide by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. Now we can go ahead and multiply straight across. 3 times 1 is 3, and 4 times 1 is 4. Check that it's reduced. It is, so that is our final answer. Number 8. So here in this case, we have two things. One, we have a whole number, so let's turn it into a fraction. Let's simply write a 1 underneath. 5 over 1 is still just 5. And with this mixed number, we're going to go ahead and change that into an improper fraction. So here we get 2 times 3, which is 6, plus 1, which is 7. So we're going to have 5 over 1 divided by 7 over 2. Now here, what I'm concerned is I feel as though some students may try to do too much at one time. They might try to multiply by the reciprocal and turn this into an improper fraction at the same time. Please refrain from doing that. First, simply turn it into an improper fraction. So here I get 7 halves. Then you can go ahead and multiply the reciprocal. So 5 over 1 times the reciprocal, which will become 2 over 7. Some students may just multiply straight across here and their answer will be incorrect. So please take it one step at a time. I'm going to check if I can cross cancel. 5 and 7 don't have anything in common. 1 and 2 don't have anything in common. So we'll multiply straight across, leaving me with 10 over 7. But guess what? That's improper. So let's divide and turn it to a mixed number. 7 goes into 10 once with a remainder of 3. So we're left with 1 and 3/7. So I'm going to say the quotient of 5 and 3.5 is 1 and 3/7. And that is my final answer. Okay, so let's keep moving on. Here we're going to go ahead and start adding and subtracting decimals. Before we actually start it, what I want you to do is to think logically. 3 and 1400ths plus 4.5. Okay, well let's think. This is approximately 3. This is pretty close to 5. So 3 plus 5 is 8. So my answer should be somewhere close to 8. If I ended up with an answer such as 3.59, does that sound reasonable? No. So your answer should be around 8. So please consider that. Okay, so we need to remember when we're adding and subtracting decimals, it's important that you first line up those decimals. Okay, so I'm going to go ahead and do that. I'm going to write 3 and 1400ths, and then 4 and 5/10. I'm going to go ahead and make sure the decimals line up. Okay, so this is the correct way of doing it. Now, a very popular incorrect way of doing it is some students have the habit of pushing everything towards the far right. Something like this, and then they add it. And they get something like this. And then they don't know where to put the decimal, so they just decide on something. Now, remember, we said the answer should be around 8. Is that anywhere near 8? No, so this should be a red flag. This is incorrect. Please do not do this. Again, we're lining up the decimals. Here, notice there's no number underneath it, so you can just put a 0 as a placeholder. 4 plus 0 is 0. 1 plus 5 is 6. I'm going to go ahead and bring down that decimal. And 3 plus 4 is 7. So I'm going to say that the sum of 3 and 1400ths and 4.5 is 7 and 6400ths. But let's think for a second. Is that close to 8? Yes. So my answer is reasonable. But here, when you got an answer of 3, did that make sense? No. So please make sure you think logically and ask yourself, does this make sense? Is my answer reasonable? Okay, so remember, do not commit this common mistake. Okay, so now at this point, I would like you to go ahead, pause the video, and try number 9 and 10 on your own. Okay, so let's see how well we did. See, the tricky thing is you're thinking, okay, I see 8, but I don't know where the decimal is because there isn't one. Let's go back to thinking logically. Here, we can say that this is about 3. It's pretty close to 3. What's 3 plus 8? It should be around 11. Okay? So, now how could I do this? How could I remember when I'm not sure about where the decimal goes? Well, think of this as 8. How would you write $8? Would you write $8 like this? Or would you write $8 like this? Would the zeros go here or go here? Think logically. What makes more sense? Obviously, this should be your answer. So with that said, hopefully you lined up the decimals. like so, and then simply add it and be left with 10 and 73 hundredths. Now, if you thought in terms of money, you probably would have been able to get this answer a lot quicker. Think of it as $2.73 plus 8. What is it? It's $10.73. Not some of you would be able to do this in your head. So please consider, if you're not sure, relate everything back to money. It's extremely helpful figuring out where the decimal goes, figuring out what your answer might be. So please remember that as a tip. So here I'm going to say the sum of 2 and 73 hundredths and 8 is 10 and 73 hundredths. For number 10, once again, hopefully you line up that decimal. And again, think here, this is about 7, this is about 6, so my answer should be somewhere around 13, because 7 plus 6 is 13. So once I line up those decimals, notice you had to put a placeholder here. You should end up with 13 and 648 thousandths. Remember, with adding as well as subtracting, you bring the decimal straight down. So here I'm going to say the sum of 7 and 21 hundredths and 6 and 438 thousandths is 13 and 648 thousandths. Now at this point, I would like you to go ahead and pause the video and try the same thing, except now you're going to be subtracting decimals. So go ahead and give it a shot. Okay, so let's see how well we did. Again, key rule with adding and subtracting decimals is you need to make sure you line up those decimals. But again, let's think logically for a second. This is about 9 because we're going to round up, and this is about 4. So 9 minus 4 is about 5. So my answer should be somewhat close to that. So here, lining up those decimals, I'm going to go ahead and subtract. And I'm going to be left with 4 and 89 hundredths. Now, is that pretty close to my estimation? Yes. Now, if I ended up with, I don't know, an answer like 8.22, now would that seem reasonable? No. Why did I come up with that? Well, some students, once again, may not consider to line up their decimals and do something like this and make a huge error. And why would I do this? Again, I'm trying to prove to you, if you think logically, if this is about 9 and this is about 4, our answer should be somewhere around 5. And this is around 5. Now, is this around 5? No. So that should be a red flag for you. It's really important that you remember to line up those decimal points. Okay. So in the next one, again, hopefully you remember with a whole number, the decimals goes right behind it, because you could think of, hey, $6 looks like that. And then simply subtract. Now here, just a quick reminder, remember you can't do 0 minus 2, you're going to have to borrow. You cannot borrow from a 0, so you're going to borrow from the next number. So one way to do it is think, okay, well, I'm going to borrow, I can't borrow from 0, so let me borrow from 60. How do you borrow from 60? Well, if you take one away, you end up with 59. So that's one way of doing it than the traditional, okay, 0 becomes a 9, 6 becomes a 5. So that's just one way you can do it. So this becomes a 10, and our answer should be 5 and 88 hundredths. Once again, please remember to line up those decimals. And once again, our answer makes sense. 6 minus about 12 cents is $5.88. Okay, so here with multiplying decimals, what you're going to see is basically you line up the numbers closest to the right. You're going to multiply it across, and the key thing to remember is in order to figure out where the decimal goes, you need to count how many spaces it is from the right. So here you're going to count 1, 2, 3. So you're going to do the same thing for your final answer. Start from the right and move 3 places. 1, 2, 3. Now notice with multiplying, it's different than adding and subtracting. You don't simply just bring down a decimal. You have to count the decimal places. So please make sure you do that. Okay. So now I want you to go ahead, pause the video, and try number 13 and 14 on your own. So here for number 13, hopefully you lined it up on the right side. You went ahead and did the arithmetic and then counted how many decimal places there were. There's a total of 1. So you did that, place your decimal point, and there is your answer. 3,131 and 4/10. Number 2, same idea. You're going to line it up against the right side. And then here, multiply. And then before you're done, you're going to count the decimal places. So counting, there's 1 here. There is 1, 2, 3. So I'm going to repeat the process here. 2, 1, 2, 3. Put my decimal point. And notice I do put a 0 in front. It is customary in math to do that. Okay. So there you go. Now let's go ahead and move into dividing decimals. So what's important to remember is your first number is your dividend. This is the number that goes inside. So 255 divided by 2 5/10. The first thing you need to remember is to move the decimal place by counting how many places it is from the right. So here we're going to have to move it a total of 1. So you're going to do the same thing here. However, I don't notice a decimal point anywhere here. So again, I'm going to think of money. This is 255. How would I write $255 with a decimal? Well, I would write it like this, right? So I'm going to go ahead and put my decimal at the point at the very end. I moved it once here, so I'm going to do the same thing here. Next thing I'm going to do is bring my decimal straight up and start dividing. 25 cannot go into 2. It can go into 25 once, with the remainder of 0, bringing down that 5. Can 25 go into 5? Nope, so I'm going to put a 0. So that leaves me with 5, bring down that 0. Can 25 go into 50? Yes, it goes in 2 times evenly. So I'm going to say that the quotient of 255 and 2.5 is 102. So here, what you want to do is make sure your divisor, the number that you're dividing by, is a whole number. And for those of you who are wondering, how did 2.5 become 25? You essentially multiplied it by 10, which required you to multiply the dividend by 10, which increased it to 2,550. Okay, so if you're just wondering, that's how it happened. Okay, now let's go ahead and pause the video and practice some division. Go ahead and try number 15 and 16 on your own. Okay, so with number 15, hopefully you went ahead and moved the decimal so that you are dividing by a whole number, moving it 1 decimal place to the right, doing the same on the inside, which is going to leave you, once you divide, is 1 2/10. So it did go in evenly. Next, here, number 16, same idea. The first number is what goes inside. The second number is your divisor that goes outside. You want to make sure this is a whole number. In order to do that, we're going to move our decimal once to the right, and we're going to repeat the process on the inside. So again, what essentially is happening is you're multiplying this by 10. Therefore, you'd have to multiply the dividend by 10, which makes the numbers different. Okay, so here we're going to go ahead and divide. Should leave you with 4 400. So I'm going to say the quotient is 4 400. Well, guess what? That is going to conclude the lesson for today. Hopefully you learned how to go ahead and add, subtract, multiply, and divide fractions, as well as decimals.